Okay, here we are with my Algebra 1 class on Monday morning, and we are going to do Friday paper questions. And we're going to start with numero, what is that? 1, 2, 3, 4, 5. Numero 5. Choose all expressions equivalent to 13 plus the absolute value of negative 9 minus 12. Will somebody help me evaluate 13 plus negative 9 minus 12? Somebody willing to work it out with me? I have lots of people on this call. Asaya, I heard you volunteer. Asaya, what's the absolute value of negative 9? 9 minus 12. All right, now what do I do next?
13 plus 9.
What do you get?
I don't know. 22.
22 minus 12. And what's that?
10? No, that's not 10.
Yeah, it is.
Oh, okay.
You got it, 10. So we're looking for anything, any of these down here. These they're called numerical expressions that are equivalent to 10. How about A? Anybody? 5 squared is not 10. What is it? 25. Boom, crossed it out. Negative 5 plus negative 5, what does that equal? I owe you $5, and then I owe you another $5. So now, yeah, thank you, Jacob. Now I owe you $10, so that is not equal to 10. How about the next one? 3 times 5 minus 5. What is that?
10.
Perfect. 15 minus 5 is 10. So definitely C works. How about letter D? 10. Okay, 16 divided by 4 is 4. We do the division first. 4 plus 6 is 10. How about the last one?
10.
3 squared is 9 plus 1 is 10. Okay, the reason I put this type of a problem is this is a clear slate / I learn type of problem they like to throw at you. So I just wanted to get you familiar with that. Number 8. Oh, sorry, number 7. Let's go down to number 7 because I want you to know what I was trying to accomplish here. It says choose all the linear functions, okay? So this puts together a couple of things that we did. For a while there, we were talking about how we know if something is linear, how we know if a function is linear, and then how we know if something is a function. So if I have, and I'm actually going to draw this like it's on a coordinate plane. I know that looks like just a line just stuck there, which it is. It's weird, but imagine it on a coordinate plane. Would letter D, would it pass the vertical line test? In other words, if I took that pencil and went like we did on our assignment across like that, would it be a function? It only crosses, as long as it's crossing that squiggly line, only one time as it goes, like once. It's not like this. That's not a function because if I put a vertical line through it, a different color, boom, it crosses it here and here. It means that there's a repeating X value, right? So D is a function, but is it linear? Is it linear? D. No, Mrs. Golding, it's a squiggly line. So it's not linear. It is a function, but we want to have both. So A, is it linear? And is it a function?
No, it's not linear.
Letter A, why not?
Because it won't pass through the origin.
I love that you just said that. So This actually, do you think it will or won't pass through the origin? What's the y-intercept of A? Plus,
It's 0.
yeah. So is that the y-intercept, 0? Goes down. And then
So it would go through the origin.
it would, and then it has a slope of -3. So down 3 over 1. And then I could draw my line. Is it linear?
Yes.
Mm-hmm. And for every x will have a unique y. No, I always say that wrong. It is a linear function. So A is a linear function. How about B? Let's try some values and just see really quickly what that would make. Y equals x squared minus 1, x's and y's. Let's try -1 for x. Let's try 0. Let's try 1. Let's try a negative. Mrs. Golding's making a mess here. Let's try, boom, -2, -1, 0, 1, and 2. Let's just plop them in here real quick. So if I put a -2 in for x, -2 squared is 4, minus 1 is 3. So when x equals -2, y equals 3. When x equals -1, what does y equal?
0.
Beautiful. When x equals 0, what does y equal?
-1.
Beautiful. And when x equals 1?
0.
And when x equals 2?
3.
What do you notice? -2, 3, -1, 0, 0, -1, 1, 0, 2, 3. What do you notice about this graph that I just made just by substituting in points? Is it linear?
No.
No, it's not linear, but is it a function? Does it pass that vertical line test? Are there any x's that repeat? No x's repeat, but y's repeat, don't they? And that's okay. Y's can repeat in order for it to be a function, but it's not linear. So this is not a linear function. How about C? What would that look like on a graph? Y equals 4.
That would just be a point.
It's a point, but what it means if it's y equals 4, it means y always equals 4 no matter what. It's actually a line, right? And the slope is 0. Because like if you had mx, it's a slope of 0. Anything times that x would be a 0, right? So it'd be like that. Is that linear? What I just made? It is linear. It's a horizontal line. And is it a function? It is a function. Now, if it said x equals 4, that's linear, but it's not a function because it's a vertical line. So far we have A and C. And now let's check about E. In order to be linear, first of all, to be a function, there can be no repeating x's. Does it pass the function rule? It passes the function rule because none of those x's repeat. But does it pass the linear rule, which means it has to have a constant slope, a constant rate of change? So what's the rate of change? 6 to 8 is plus what? 2 plus 2. 8 to 12, what do you get?
4.
4. 12 to 16?
4.
Good. Okay, -2 to -1.
1.
1. -1 to 0. 1 and 1. So my change in y here is 2 over 1, and here it's 4 over 1. So the slope starts like this and then goes up, right? That is a function, right? But it's not linear, okay? So my answers are A and C. A and C. Okay, let's do number 8. Choose all the numbers that are greater than 1.64 times 10 to the 4th. Who can help me with this? What would you do? Anybody have a thought?
I do, Miss Owen.
Please tell me.
So what I would do is I would look through them,
Mm-hmm.
and then you have to have one with an exponent equal or higher than it for it to be greater than.
Okay.
So then I look through those, and there's only the last 4 do them.
Okay.
The D, it's got a smaller first number, so it can't be bigger than it. And then the other 3 will all be bigger.
So this one you're ruling out right away because 1
Same
and 3, because it's got the same exponent, but the first number is smaller. I like that logic. You keep going.
I would also rule out A because it's got a smaller exponent.
Great. And it's the same place value, right? There's only 2. So that'd be really just 203 if I worked it out. Okay, keep going.
And then B would be correct because it has a higher exponent. Same with C and E.
B, and then C and E. Okay, so let's look at E. If I move 7.098 and I move that over 1, 2, 3, 4, 5, I'm going to get 709,800. That's bigger than 16,000, right?
Mm-hmm.
This one for sure. This one for sure. So B, C, and E. Excellent, Thomas. Very nice. Let's see. I put on, make sure it matches my paper. Yes. Yes. No. Yes. Great. Number 9. Oh, this is what I did this morning. So I went down and asked Mr. Burris. I found this cylinder. Can you see it on my screen? Cylinder. Tell me what you know about a cylinder. It's like what in real life? When do we see cylinders? Like I always think of a soup can, a pop can. And pop can's not exactly a cylinder, but right? Okay, so this says choose all the true statements about the shape formed when a cylinder is sliced perpendicular to the base. Okay, so I'm holding it like this. So does that mean this curved side is the base? What's the base of a cylinder? What does that word base mean? So when I'm thinking about bases, I'm thinking about a non-curved side, so it's flat, and a cylinder actually has 2 equivalent bases. This one and that one. And what shape are the bases?
Circle.
Circle. Circle, circle. And they're exactly the same size. That's what makes it a cylinder. Okay. So this says I'm going to take this cylinder and I'm going to slice it perpendicular to the base. So if it was parallel to the base, you could imagine a slice going like this, right? That would be parallel to the base. If it's perpendicular, it's slicing it like this, okay, chopping it down. So I'm going to take this, and I asked Mr. Burris to cut this for me. Okay, so there we have the inside. So what I did, I just took it apart. Boop, cylinder. Okay, there we go. And so let's choose the things that are. Did it form a rectangle?
Yes.
Yes. So I'm going to select A for sure. Okay. Yes, it formed a rectangle. B, it has 4 right angles.
Yes.
Yep. Okay. C, it forms a circle.
No.
What does it make?
A semicircle.
Good, semicircle. So not this one. And D, it forms a semicircle. I think I just said it, didn't I? Throwing things around. Semicircle. So perfect. My answer is A, B, and D. Good? All right. So hopefully that's a good start on your Friday paper. Any last comments or questions about those that we did? No, Miss Golding, we're sleeping. All right. All right, we're going to go ahead and stop the video. Remember, we're going to do more of them in class, so be looking for those. Have a good day.